Hello. No countdown today. It's going to be a shorter stream. Sorry about the delay. Ended up into some scheduling issues. Adrian is still not with us. Adrian is, I believe, experimenting with a different schedule, trying to get more work-life balance. So until he resolves that, or if we need a different streaming schedule, till that's resolved, I entertain him with a shorter than usual solo stream. Today was inspired by a discussion on Nicholas Ocket sparked a interesting conversation in one of. Let me hang on. I got echo. Let me. No echo, please. Nicholas Ocket sparked a conversation in this thread that I'm posting now in stream chat. Masay, hello. It's great to see you. For those of you who don't know, I wrote a short foreword in Masay's new book, which was released this Monday, a few days ago. Masay, I do have a testing-oriented stream in mind today, but if you want to hot join quickly and talk a little bit about your book, that would also be nice. Let me know. DM me on LinkedIn if you're interested. Thanks for joining the stream. There's also a second stream going on right now about mutation testing. If you're interested in that, I just saw it pop up in my feed by Bas Dijkstra. He's talking about mutation testing. So I've linked this post. This was Andrea Els. I don't know how to. He's Italian. I don't know how to pronounce his surname. But actually, this Zoom doesn't help. So let me share and present. Which screen? This one? This one? This one. So Nicholas had a great question regarding. Basically, Andrea had a post about mocks. Please don't use mocks. Mocks are an anti-pattern telling you that your design has issues. Use stubs instead. Test behaviors and implementation details. And Nicholas had this question of, I usually use mocks to stub calling behavior on DB/ORM related features. And then this turned into a long discussion between the three of us, between myself and Andrea and Nicholas, with some comments in between. And Nicholas basically gave us this picture. And I want to highlight this picture and maybe put it into here. Do we need to go into white mode? To highlight, sorry for flashbanging those of you who are watching this recording at 2 a.m. in the morning. Oh no, actually, you didn't see that, did you? You're seeing what? Oh, I didn't share the tab. I shared okay. So basically he said, below is a graphic showing the process. I'm testing boundaries. However, I do check the values passed to the last mock. That is what is going to be inserted. So this is his design. This is his unit. This unit has a TCP server as a dependency, a DB interface. I'm assuming this is a read and write interface. And then he's testing in his last step whether everything passed to the DB was passed correctly. And his question was essentially, I have an integration test for this right now. I'm spinning up a Docker container with a fake DB. Is it worth converting this? Is it worth losing some coverage and converting this into a unit test by losing surface area on what the mock covers? The conversation was basically, it continued. Andrea's recommendation was, don't check the value passed to that last mock, check the effects of passing that value or of having passed that values. Don't use mocks, use stubs. Which is an interesting, I think a very frequent problem that a lot of you or writing integration tests are facing. Also, front-end engineers who are writing, this is a more backend related concern. Front-end engineers have a similar problem when it comes to fetching stuff over the wire or dealing with browser APIs, things like Bluetooth, or not even Bluetooth, like geolocation or things like that. Usually you would resort to some like heavily controlled but not Dockerized environment, usually with something like Playwright or Selenium or Cypress, usually Cypress. Eric had this recommendation. You didn't have to fire up a database. You could use a stub and the list for repository save, and then use the same stub to fetch it. Then depending on what you need, you get it back. So I want to over to Excalibur because I want to draw stuff. Hang on, are my colors correct? And do my colors make sense? Let's lock this. Let me move it. Okay. Yeah, colors are good. Green, blue. Blue is good. Orange is good. This red will be high contrast. Okay, all the colors are good. I don't usually draw on like the white interface. So there's that. Any questions for the audience so far? Calion, hello. Massey says, okay, some other time. Okay, I'll just go ahead and just stream. Cool. Let's close this. And I will open up, as always, need a backup for chat in case something breaks. Okay, I got questions open on 2 places now, so make sure I won't miss anything. I missed some comments last time again. I'm very sorry. I missed the check. I forgot to check. We had a similar situation. We started a bit later, and I had a few comments from Ty and others, and I missed those. I'm very sorry. I did answer them like after the fact, but like the whole purpose is so that you guys can comment. Any questions so far? So, question was, context is this: we have DB interface. This is now covered with a integration test that covers this. Nicholas spun up a Docker container that had an actual DB or a reasonable replica for it, and those got represented by the database. Andrea suggested that mocks be used and potentially redesign what this interface is doing, so that then when you know what the mocks are returning, that you can test the behavior of your system against those return values. Usually the argument is, yes, but then isn't my test realistic? Aren't I testing less? And the answer is usually yes, you are testing less surface area. But we don't want to optimize for that when we're testing like this. What we want to optimize for when you're writing tests is how fast they run and how stable, how reliable the run is, how many variables you control. Anything that usually, if you use Michael Federick's definition for a unit test, everything that touches, date time, file system, any kind of hardware, like explicit hardware meant for state management or memory management, the network, it's not a unit test anymore. Now, it's arguable, right? So if everything is in memory and I'm talking to another process, if I have to talk to the other process using the kernel, that would also be state. Even though it's all in memory, that will also not be a unit test anymore, because I might have to go to the operating system, and the addresses might be unique. But then you can split hairs as much as you want. The point is that Nicholas asked for alternatives. The agenda for today is focused on why does this happen. So the agenda is, our talking points for today are the following. Why does this happen? What's the root cause? How can we address it? What are the benefits of addressing it? And what does maintenance look like? Vladdy says, did you just say testimize as in optimize tests? Cool name. Yes. It's my word salad of the day. Testimize. Yes, we're optimizing testimizing. Okay, I'm just gonna go with it. Okay, we're testimizing Nicholas's use case. We're optimizing the test. So why does this happen in the first place? All right, so I realized that streams where I show the editor and I don't have a prepared example, so I'm not fluent. I'm talking while I'm writing code. It's very much unfun. So I will write pseudocode instead and draw. And analytics tells me that you guys like that more. Now, whether that's accidental or deliberate, I don't know, but I'll just go with what the data tells me. So instead of code, I know a lot of you would like to see code, but then if I get the language wrong and you prefer Ruby and I'm doing a code example in TypeScript, then that's also an issue. So I will draw, and I will primarily, whenever necessary to use code, I will write pseudocode. I will only put up this disclaimer once, and then possibly not have to deal with it too much this stream. So usually this happens. Let's say this flow. Let's just assume it's a function. It's possible that in Nicholas's example, it's a class of some kind, and then it has a constructor, and the object instance of this class has a, I don't know, execute, or maybe it has a, there's a TCP server, maybe there's a handle request method. I'm just going to assume all of that is this function, just for the sake of being able to draw less, so that we can focus more on functional decomposition rather than the actual sort of implementation details in the language that he's using, etc. So this is a function. This is this flow. Internally, it has three variables, S1, S2, S3. Those are, let's say it's composed internally. This is private. Oh, okay, P will be private protected. So let's assume this is locked. This is locked. Okay, no phallic shapes, thank you. This is a lock. Okay, I give up. Wait. Yeah, there you go. This is a lock. It's private. Nice. No. Thank you. Everything here is private. Okay. Now the flow function. Let's. I just wanna be grown up about this. Sorry. So flow, the function. Is that better? Oh. So the flow function has seemingly two parameters. It has a TCP server and the dbMock. Those two parameters. The TCP server, let's make it gray. Like this. Okay. Now, usually what happens is, we're customizing this example. So why does this happen? Right. So going back to the topic, why does this happen? This happens because if you already have generated code for you, right? So you have a database here. You have a database, and you access this database with, let's say in C# with auto-generated code, which was given to you by some ORM. You now have a piece of code. So the root cause is, actually, I want to talk about that a little bit later. Why does this happen? This problem happens because you are using a abstraction for talking with infrastructure as one of your dependencies. That is why this happens. So this problem of I have to do it with the integration test, there is no other way. It happens because this dependency is an abstraction of communicating with something outside of your boundary. So it is designed to be an interface for DB access. It's meant to be outside of Flow, outside of Unit. We have a comment on YouTube. Hey, I just joined. What's going on? What we're doing today is exploring a use case by Nicholas Ockett. He had a very typical case in a feature that he said, I find it very easy to integration test, but kind of difficult and annoying to unit test. Can I unit test it, and should I invest the time and effort that it takes to get rid of the mocks? This has sparked a LinkedIn conversation. If you're joining late and you are live with us, as in live now, so 17 minutes and 25 seconds into the call, I do suggest you wind back on YouTube. So I see you're on YouTube. Wind back on YouTube. Watch it maybe at 1.5 or 2x speed, and you'll catch up with us before we're finished. I'll prefer you go over it one more time than I have to repeat everything I just did up until this point. But it's going to be easy to follow either way. So I'll let you decide on either way. I'll see you. I'll check in with you in 10 minutes. So why does this happen? This happens because we have a dependency. We have dependency for our feature that is designed to be an abstraction for something outside of our unit, right? So it is not a domain-specific abstraction. It is an infrastructure-specific abstraction. You've probably heard about this concerns from hexagonal architecture or clean architecture, domain-driven design, right? So the type of the dependency is what's causing the problem. Now, what is the root cause? Check. What is the root cause? Well, the root cause actually is that we're talking to a database, and talking to databases, particularly SQL or one of the more known databases like Redis, Mongo, etc., Cassandra, ClickHouse, there's so much code written nowadays for communicating with them, managing migrations, that I think most people would prefer some kind of adapter layer in between their code and the database. Or in ORM, in C#, you would generally use the most dominant current Microsoft sanctioned framework to communicate. In TypeScript, you'd probably use TypeORM or something very similar to it, or Prisma. So the whole point is that the ecosystem very heavily incentivizes you to use some form of ORM, which is then creating this kind of abstraction, which causes that problem that we discussed earlier, right? So the problem is this is an infrastructure nuanced dependency. What does that mean? It means that whatever generated this code did not know about this use case. So the infrastructure generated ORM, the entity classes which you use to communicate with the database, they are optimized more to the flavor of the database and the tables, more that than the flow, right? So it is very cohesive with your database and infrastructure, and pretty much not cohesive at all with what Nicholas is trying to do here with this flow function. That is the root cause. And if you now want to, and that is also the reason why you didn't need a mock, because then you need a mock to replace what that abstraction represents. That abstraction represents a database, a specific form of database infrastructure that has a specific form of usage interface, in that case, whatever the flavor of the ORM is, and then you need a mock for that. No, that is then why this becomes messy. And I'm assuming this is the read side, and this is the write side, and I'm assuming what Nicholas was doing was setting up the database, setting up something to be read, so it had an entity. He started running the test. then read the mocked entity. They did stuff with the TCP, and then this wrote into the DB. And then after the test was done, he would check, okay, what is now, is the written stuff in the DB correct? Right, so it is heavily, all of the assertions and really complex, all of the complex behavior in the test itself has to be wired through the mock, which makes this a very messy test. It also touches them way too close to implementation details. You have to touch on like what function is calling whom, what are the dependencies of the function, what is the current signature of the function. You then create a test where you're kind of explaining behavior, but you can't explain the behavior without using internals of the mock, which are bound to implementation details, which then makes the test brittle because binding to implementation details makes it difficult to refactor the unit on the test. The behavior is not clear. The boundary between implementation and behavior then blurs. Plus, you also are heavily dependent on whatever mocking framework you used, because I'm assuming you're not mocking by hand, right? So it just creates all of this unnecessary complexity. So that's the root cause. That's also why we usually recommend, people like myself and Andrea, why we recommend that you don't do this, because the essential complexity of what is being tested is much less complex than the infrastructure around testing it, just because of the mock and the infrastructure introduced by the integration test, right? So either there will be a Cypress in here, or a Docker container, or a very much ORM aware mock. So the mock will be aware of kind of the design of whatever the ORM was that you're using. So how can we address it? There's two ways to address this, and it depends on certain details. I talked about one of them in the post. Andrea also mentioned one of the solutions. Andrea basically said, this is your code, so let's do the two solutions, and let's then talk about the trade-offs. So we have option A and option B. Let's make this a little bit bigger. So we have option B, we have option A. Nah, actually, it's just annoy me. Okay, now they're the same size. Cool. Awesome. Which button is it? This one? That one, yes. Okay. So what we can do in option A, we can say, here's your flow stuff, and it's communicating with the database somehow. There's an interface, there's an API to communicate with whatever is being injected to represent either the entity or the repository of some kind. So what you can do is you can take advantage of it fully, and you can just replace this entire thing with a stub. You can replace this entire thing with a stub. And then the assumption here is that where this interface is, so adapting the port side on the unit under test. This is the unit. The port side on the unit should only really be setting expectations on what this returns and what is being passed to it. Now there's an issue with this. If the ORM code is very complex, then it's possible that this thing accidentally exposes some kind of query language, which means that there's probably going to be some query builders involved, some lazy loading involved. If I save the entity this way, that might have an auto-generate ID. So there might be some spooky magic in the distance going on with how you're using the entity. If the entity was sort of bound with a repository given by the ORM, and there's some query building going on behind the scenes. It's possible that then if you build a stub, you will then create like this fake ORM thing for testing purposes. And that's really annoying. So if there's behavior involved with your ORM entity, this is going to cause problems. But if it's just, save, if it's just save and find, find by ID, new, then you can just stub these, check what they return. Hopefully the objects also aren't too complex. Right, so if there's a lot of Demeter violations here, right, so if this entity has relationships to other entities, and the relationships, the joins are expressed as a collection, and this collection again is then, if this is ORM for the infrastructure, if these collections are then expressed by types exposed from the ORM, then the stub you create will be of equal complexity to just using the mocked ORM. So this isn't going to go far. But if it's just simple save and find, right? So if the ORM, if the usage scenario can be reduced to a collection, so in C# you would say that this is some form of I collection, or I iterable, this is some form of I collection, and that it has the entity in it as a generic. If it can be reduced to that, or some form of lazy loaded iterator that exposes this, then you're good. Replace this with a stub, or with a service, or with the function that returns this stub, you're golden. That's one of the solutions. You might not be this lucky though. So your mileage might vary. I recommend that you try to extract the explicit domain behavior from it, rather than this idea that this is something from the database. This is option A. Option A is going to lean on, so let's just say what option A is. Option A says stop the DB interaction instead of using a mock. This means, right, the condition is that the operations for the underlying interface are, I collection compatible. Now, whatever that I collection is, in some languages, it just might be an iterable of some kind. It might be a collection of some kind. But I would very much want it to sort of stay at the lowest level of, it might be a function that returns a collection. So think of this as hooks in React, or this concept of a proxied lazy loaded array or collection of some kind, right? So the whole point is that this API, when it says find, that the find function doesn't have, 6 different parameters that are in some complex way bound to query building or ORM specific knowledge from the ORM itself. That's the key element here. So it requires some redesign. Now, option 2 is, which is, I would always recommend this one if you already written a lot of code here, and the mock will so there's a benefit to this. The trade-off is, here is that you're still bound to ORM design. If you change your ORM, if you change your entities, it's very likely you have to, these tests will just break for no reason. The good news is that this particular solution is very easy for wide coverage on legacy systems. So if there aren't many different types of queries, like read or write, if it's just read and insert, then you can mock sort of this repository once, and you get a lot of surface area for a lot of different tests. However, this doesn't work well when you have a lot of different types of entities, right? So when your entity graph is like 40 different tables, and one aggregate touches like 17 different tables, then you're not really benefiting much from this, because you'll just have to maintain mocks and stubs of different relationship hierarchies. And at that point, you might just spin up a Docker container and simulate the real thing. The other approach, option B, for handling with this situation, which is what I recommended to Nicholas in the LinkedIn conversation in the comments, is actually ask yourself, what is the behavior of persistence? Right? So this question is supposed to trigger a sort of inspection of, is there any side effects of us using a certain save or find or persist strategy that causes state to change? So when I'm going through this flow function, there's multiple steps, and then at the end, something gets saved in the database, and it depends on the initial state and what came in from the TCP server, right? So if I'm retracing these steps, the value of the final mock depends on the initial mock's value, the TCP server, and the particular 3 steps, right? So the question is there some kind of behavior involved with persistence, right? So does it auto-generate something? Is there some non-trivial way of how certain elements are handled? Maybe there's some JSON conversion going on. Maybe there's some relationships, some foreign keys going on that have to be synchronized, right? So that I would file under complex behavior, but complex persistence behavior, right? So the persistence mechanism itself has behavior. So what I would do is I would then extract that into a domain concept where I would give a explicit interface where I would say that there's an interface for, I don't know, auto increment identifier persistence, right? So this is now, I agglutinated on purpose to prove a point of how silly this is, but I would explicitly define what the behavior is from the ORM that I'm relying on in the test. Because then maybe I can just stop this part and then separate this part from the actual state mocking that I'm doing. Because then I might make a stub that can replicate this behavior and then use simple collections, like an in-memory collection for the rest. But I would make it explicit because this might carry some interfaces. This might carry some interfaces that have some functions from the ORM, but at least this way I can rename them and I can proxy them in the actual implementation. This then gives me sort of an inversion point for the interface where I can replace it with something that doesn't, at least in the test, it doesn't expose the surface area towards the test. In hexagonal architecture, I'm creating an adapter to hide the fact that there is an infrastructure-facing port on the domain concept that I'm testing. Of course, you wouldn't call this auto increment identifier persistence. You would call this I don't know, a numbered save, right? So a numbered save, or you might call this an auto increment entity, however you want to call it. Then I would just maybe have the save operation, the save and the find. This is a numbered save. So every time I save an entity, it receives a number. And then I would have 2 methods on this interface, and it would be save, and it returns the number, and it would have the find operation with this number. And if you're a fan, of domain-driven design, you can then use value objects or named tagged templates in TypeScript, for example, where this number would then actually be a value object representing an ID or even a core domain concern related to this entity. Right? So I would then design at least this part that is problematic, that expresses the behavior that we want from the persistence layer, to be modeled explicitly and carried into the domain layer, so that when the domain layer is being tested, we know that the domain layer depends on infrastructure details like nuance, but it is expressed using domain language, right? So I'm deliberately using plain English here. I'm not using database concept. I'm not calling this a sequence. I'm not calling this an auto-generated ID. I'm not calling this an auto-increment column. I'm not calling this some kind of ID column that has auto-increment, because I am specifically going away from database jargon and I'm trying to stay in domain lingo. If we don't know what Nicholas's domain is, if it was accounting, maybe this would be some form of invoice ID, right? So maybe this would be some kind of save operation that saves the invoice using invoice IDs, right? So it would be invoice ID save, or save using invoice ID. So what I'm capturing is this behavior that the persistence mechanism is using some kind of domain concept, like this value object capturing the identity, or at least the lookup field, as that being an important detail. And then when you save it, this then has some, a cog in the background, and then it like spits out a number, and there might be a rule of how the numbers are spat out. So then I might actually have a contract test that says, if I call this 1,000,000 times, there's no duplicates. And if I call this 5 times, then there is a stable sequence and they are numerically increasing. Right? So it might be that the numbers have to increment or that there are no duplicates. And then I might have a contract test to actually test the stub to make sure that this is actually happening. That's one way of getting rid of the integration layer or the test. Another way of getting rid of it, if we go back to the flow of the dependency, it would be to get rid of the dependency. Right? So right now the flow is, this flow function has, is that my mouse or lag? It's my mouse. So the flow function has this, we give it the entity, and then something along the way has a save method, right? Well, what you can do is you can inverse the relationships between these objects and say, right? So Nicholas drew it specifically because you can see step 1 is calling the database, and step 3 is writing into the database. So if I create this flow object, where's my diagram? Yeah. This dependency, the read side of the dependency goes to S1, and the write side of the dependency goes to S3. So instead of modeling the primitive, what you can do is you can say, okay, hang on. That's like a proxy dependency, and I'm just using some dependency injection framework to auto-wire stuff, and then I'm doing this sort of law of Demeter violation and passing, give me the thing that gives me the thing that gives me the thing, rather than just giving me the thing. What you could do is you could inverse the relationships in such a way that you have, step 1. So in addition to this above in option 2, you would then have these 3 steps and the flow function. And then there's the, the read and the write. Hang on, I will annotate them. So this is read, this is write, and these are step 1, 2, and 3. Right, hang on. I can do salami. Okay. And now I can do, yeah. Boom, boom, boom. This way. Cool. So rather than doing this, to go from this to read it from outside, right? So get the entity before you call the flow function. Wrap this into some kind of use case. So the use case only knows how to read. And then you give this the part of the entity, so the part of the interface, expressed as a different object to step 1, so that step 1 doesn't know about the database. So Step 1 doesn't know about the fact that we have fetched something from the database, right? So the information, so I'm assuming the most natural way of handling this is that this TCP server, it might have an, I don't know, it might carry some kind of ID, and then the step 1 is taking the ID from the TCP server, from the network layer, and then it's fetching something from the database corresponding to that ID. What I'm saying is that maybe there's a use case, it gets the ID, fetches the thing, and then you instantiate the flow, putting the already in state object, encapsulating the correct behavior of what the next steps are from the smaller subset of what came from the database. So step 1 doesn't know how to read this thing. Or at least if you then convert this to a smaller subset of that object, that at least you can inject a memoized function that will not, maybe not contain the object, but it will be a function that knows how to fetch or refresh the object. But it only refreshes an object with a certain ID, and this function doesn't need to know what the ID is. Right, so think of it like a fetch operation, but it was already, it was like the ID that it's fetching is already pre-bound, and you only get like a subset of that function that can only refresh the data, but it doesn't have full access to the repository. And then you go through this, and then in the same vein, rather than giving it full access to a repository and an entity, you inject into it from the use case itself an adapter that only knows how to update the state of the thing that you were given. So it's not full write operation onto a repository and full read operation onto a full write and full read operation onto a particular entity in a repository, but instead you already highlight the ID that this will be relevant to. So you create a reader for that ID and a writer for that ID, which in most cases would be that entity, but as two separate concepts. So think of it like the ORM designing something for you where the read side of the entity is a projection and the write side of the entity or the aggregate is a command. But we're injecting these two things, right? So we're injecting into the flow function, this is now using terminology from event modeling, we're injecting something that can refresh the projection. So I can read the data from the past. And we're injecting into another command that can produce side effects. So a command that says, okay, I'm synchronizing with past state, I am now locking consistency, and I am communicating, I am making a side effect, I am making a permanent record, I am making a change. But only to this entity, right? So in event sourcing lingo, I would have a access to a particular stream with a particular ID. I get a function where I can get recall on everything that has happened up until now, and I can add new records from that point onward. What I can't do is I can't go back and change the past. I can just say, okay, if the in-memory stuff validates and we can get here and get here, then the consequence of using this write method is that there will be a new record, like some new events, right? And now in purely event sourcing terminology, because you don't need to use event sourcing for this to work, but the pure consequence of this is now and also what Andrea said about how to test it, is that you shouldn't then test, what refresh looks like. So you shouldn't then assert against the refresh here. Don't assert against this refresh. Just assert that whatever changes had to be made as a consequence of calling the command that has side effects, that command returns something that correctly captures what the side effects were. And then you test as a separate test, and then maybe that can be a smaller integration test with a smaller surface area, so that if I get the reader that can refresh the projection, that can refresh. I see it locked into the canvas. Then that you would have a test that says, hey, if I do a read plus I write entity 1 and then entity 2, then it follows that when I read that it is consistent with the new state. And then you just have a integration test for this. Right? So basically you say, if I read from a projection and I put this into the database and I make these changes to the entity, then when they read it back again, I will have the consistent state. So then you can just write an integration test for that. Right? So you just write an integration test for what it's like reading this entity, commanding it to change, and whether then a reread is consistent. And then you would abstract this interface, and then that is what you test against. Right? But don't get me wrong, like you would test from inside this surface area. Right? So you would have a use case, again, this concept of a numbered save can be captured, right? In event sourcing, this would be your stream name, your stream ID. If you want to capture that this is an SQL state-based persistence, you can capture this as some kind of sequence, but it doesn't matter. What matters is that you have this concept of I can read from and I can write side effects. I can perform a command. And then I have my flow entity with step 1, step 2, step 3. And I'm injecting the refresh command into step 1, and I'm injecting the command into step 3. And then I can, specifically the refresh query and the change command, right? Step 1, step 3. And then you are testing against that. And then those are unit tests. And then this is a integration test, a much smaller one that you can then throw against a real database outside of the concept of flow, with what would be a normal output of that flow, to test whether it also follows the same rules when you throw it against the real database in the real world, in a real life scenario. But the point is that the service area of the integration test is much smaller and has much wider reusability, while your flow, your domain logic retained, like it stays in memory. So those are the two options. Again, the meat and potatoes is this. Now, what are the benefits of both options? Here I already said the benefits are if you have a huge legacy system that has it has like a huge ORM and all the reads are primitive, all the writes are primitive. There's no analytical queries, there's no complex joins. If you just go in and create a mock for your ORM or use mocks supplied or stubs supplied by the ORM itself, and this is quite popular in things like Laravel and things like Entity Framework, then you can cover a lot of surface area. But it'll also make it very difficult to test those few exceptions where you have really important critical user journey that require the custom query. And then it's going more into that no-code, low-code space where you don't need to think about design too much, but your architecture, your abstractions will sort of underserve your overall complexity, and you'll always struggle. You will always be one step behind in your testing capability to what you would wish it is. The benefit is that it's relatively cheap if what you want and what you're satisfied with is clumsy tests. Nicholas is pinging me. I'm thinking. It's Ty. Hi. Hey, Ty. Glad to see you. Did I miss chat? Did you type something in chat? Please tell me chat is working. The second benefit, so the benefits of option 2 is, if there's behavior and persistence, capture that, but capture it using a domain-specific interface that captures what the persistence, but the side effect of the persistence, what the nuance of the persistence behavior is on using plain English, using that side of the domain barrier, as an adapter, and then separate out the read and the write side, and make it more. I like to use event modeling terminology, so make this more. This is a command. I am permanently changing state. versus this is a refresh. I'm never doing the same at the same time. Right? So I'm always reading before I'm commanding, and when I am commanding, the command itself might give me the side effects of what it changed, but it shouldn't carry the side effect of what the new state is, unless that's part of the right. So unless you have an insert statement in your SQL flavor that can return back a set of rows without you selecting, then I wouldn't model for that. Right? So in SQL, an insert statement, it's actually very difficult to reread the same row in the same statement, because insert statements can affect multiple tables, and they can have side effects, they can have triggers, right? So there's a consistency boundary even within a single node. But if you're using like master-master replication or write-ahead log binary replication, what can happen is that you might be writing and reading from different nodes. So even in SQL, you might have a consistency problem. But if it's just a single table and you're just basically locking it and you're writing and reading to it, it might be normal for you to assume that writing and then refreshing the entity, or even not refreshing the entity and just assuming that whatever you have in memory given by the ORM is in a consistent state. That is inherently like a clumsily designed system. What you really want to capture is that, as Andreas said, and I think that's what he alluded to, is that the command should return to you what it changed, not the new entire state of the entity. Because that new entire state of the entity now needs either needs a consistency bypass and needs to sort of maintain like a transaction, then read, write, read, and then it has to give you like some strong guarantees, and this sort of SQL language like starts seeping into your domain abstraction. Or the guarantee that it gives you is actually a lie, and there are some caveats in there that have to be resolved with certain forms of idempotency, and your abstraction is going to be underserved, and it gives you this sort of fall, like this fake, immediate consistency guarantee. I've seen this plenty of times, even like a simple Symfony application where people do a simple form processor. They run into these issues and they never know how to solve them without using like transactions and table locks. And I just find it silly. Like, you don't need to do transactions and table locks for just updating a record somewhere. So if at all possible, the crucial detail here is that it'll allow your domain to say, okay, when I get to step 3, I write, and the return value, the write is not a void operation. The write tells you what it changed, and then you can assert against what changed and whether the changes were correct. So that would be my recommendation. Those are the benefits. What does maintenance look like? If you're on option B, then maintenance is mostly focusing on areas of, if we're adding complexity to this behavior, or if you're renaming it, or if we're changing, if you have multiple different write scenarios, right? So if the flow becomes more complex, the maintenance part is really, if this can return an array of changes, and let's say they are events, the maintenance part goes into detail of what is the schema of these events, right? Because the schema of the changes can be different from what is in the database. The database just has the final state if it's state sourced in an SQL database. If it's event sourced, you're good, you're golden, you already did your homework. But if you're doing this kind of API with a state-based persistence in an SQL database, or like a flat database, like a document DB, then you'll have to sort of somehow maintain rules about like what possible events can I get back, because you need to replay them, you need to sort of reason about them. So it would stand to reason that these events, and particularly the schema, what's going on? Is that my mouse? That the schema of these events and backward compatible, which is a very strong guarantee, which requires a lot of deliberate and very pedantic API design for this level of, for just a return value of like a benign looking stub or mock or function, right? So a lot of work will go into maintaining this kind of schema. So it's like there's no, because if you change the schema, then a bunch of your old tests might fail, even though the end result in the database is still the same, but you might change the schema benevolently, but then forgot. You basically make your tests brittle, which loses you the main benefit of using this approach if you don't commit to keeping the schema backward compatible and versioned in some way. It needs to be versioned because you want it to be backward compatible. If it's not backward compatible, it also doesn't need to be versioned, right? So that's up to you. You can also make new additions optional, but I find that to be a lot more hassle than worth. Like backward compatibility plus versioning is a much better option. Maintenance on option A is basically your mocks or your stubs might be coming from a framework derived from the ORM or a very intelligent mocking framework, or maybe you're auto-generating stubs from like you're constantly adapting stubs to your databases, which means that you need to now do two things. You need to make sure that the stubs match actual SQL schema, plus you need to write contract tests everywhere where you're using these stubs or mocking instead of using the stubs to make sure that they are integrating correctly, because your code will still be in memory with a unit test using some form of like flaw integration. But if every time you're using a stub or a mock, that then exposes two kinds of behavior. If the behavior is oversimplified, you still need to capture, okay, what am I replacing this with in production, and then test that in isolation against something more similar to what's going on in production, without sending it through all of the possible domain concepts, right? So this comes down to domain composition. So the maintenance part here is that if you have, I'm going to use colors here, forgive me. So if you're listening on the podcast, blue is the color I used for domain concepts, and orange yellow is what I used for infrastructure stubs. If you have 5 domain concepts using 60 infrastructure stubs, then the maintainability trade-off is really bad. If you have 10 infrastructure concepts and they can all be used to test hundreds of domain concepts, that's great, right? So it's also about the ratio of like, how is the number of complex things that we're testing that we want to run fast? How are they in relation to the scale and scope of the database things? If you're stubbing out 200 different database tables into 200 different mocks and stubs that can sort of form different kinds of relationships, and you might even have stubs for different relationships and how the ORM is putting them together in some like lazy logic collections, that's not worth it. Then use option B on the right. Be explicit about what am I refreshing, what query am I refreshing. That can be a graph. That is also then bringing you closer to the GraphQL territory, where even if the read side of option B is GraphQL rather than SQL database, it is still compatible with this idea of, oh, that's a query and that's a mutation, right? But we can, it doesn't have to be GraphQL language. I'm in my sense, the most generic sort of common denominator would be event modeling or event storming, if you're familiar with domain-driven design. So you're sort of separating out the command side and read side, but they don't have to be eventually consistent. So yeah, that's the maintenance aspect. I'm going to wrap up the stream in 10 minutes. Now is the time for any questions. So all of you who are sort of catching up on YouTube, now's the time to ask questions. Yeah, let's hear it. I'm just going to reset Canvas so everything's on screen. Yeah, do let me know if I went off track somewhere or if some of the drawings are unclear. Again, I know you will want a code example in your code base, in your example, in your ORM, in your language, but I can't make everybody happy. If you do want that, send me a DM with like a GitHub or like a kata or like an example, and I would gladly recreate this example in your context and have a conversation with you about that. That we can do. Okay, open for questions. I'm gonna stimulate you, motivate you to post your questions with some background music. Otherwise, we wrap up in a few minutes. Let me check my trusted backup chat to check if I have missed anything. Boom, 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 boom. I like the word testimized that I stumbled upon the beginning of the stream. Angel, hello. It's been a while. Yes, thank you for tuning in. Yeah, I do see that StreamYard chat is broken. Angel, I can see your message on LinkedIn. Awesome. Hey, it's been a while. Cheers for tuning in. Any questions? Let me refresh this real quick. Actually, now I'm skeptical. Maybe chat is broken. Let me check YouTube directly. No. Okay. I'm synced with YouTube. Cool. Okay then. Usually when I say that, there's a question popping in last minute. 4, 3, 2, 1. Okay. No questions. Wrapping up stream. If you do happen to have a question and miss it, I promise I do go through the comments afterwards. If you think your question is related to some context that is like too, like either inappropriate to share or too lengthy to share here now live, DM me, send me a GitHub, chat me up on one of the Slacks that I'm on, or LinkedIn. LinkedIn will get you the quickest answer. Or tune in for the next stream and we can have a follow-up. Cheers. Thanks for being with me on the stream today. This was about integration tests, how we can sort of change the design to turn them into unit tests, why it happens, what the root cause is, where the sort of ORM specific problems originate, how we can address them using 2 different strategies, what the trade-offs are, what the benefits are, and how they affect ongoing maintenance, how the 2 options affect ongoing maintenance. Obviously, I haven't talked about the ongoing maintenance about the integration test. The ongoing maintenance of the integration test is that it touches infrastructure. So every time there's infrastructure changes, you don't know whether the test is still passing for the right reason. If it fails, you don't know whether it's failing for the right reason, right? So integration tests generally carry that flakiness, despite giving you, they give you a high level of confidence once they pass and continue passing. But in between pass, fail, pass, the confidence level into the integration test is not very high, because you always have to check whether it accidentally failed due to integration-related concerns. Which is why I like talking about topics about these, because not a lot of people delve this deep into maintainability specifically. And if the tests are not maintainable, if your code is not maintainable, then your engineers will not want to work in it. Then they will not want to write new tests in it, and then that will just make life worse for the next generation, which is what I'm all about. I want every engineer to experience what it's like to be working at a very highly efficient team that can, test cover their code fearlessly. Even when they say, Dennis, I can't 3D this, our code base is a mess, I like to tell them, yes, you can, let's do it. And usually within an hour, we have a 3D inspired test that they thought was impossible. And I love those aha moments. That's what I do on private coaching. If you're interested, my LinkedIn has my relevant links. If you want that kind of coaching for the entire team, plus some leadership support, and attach me to the team and be your personal coach, as a leader or manager within the team, let's chat. This has been very lovely. You've been a great audience. Thanks for all the comments. 1, 2, 3, 4, 5, 6. Yeah, we had like 7 people on actively chatting in chat. See you next week. Hopefully Adrian will sort of resolve his scheduling issues by then. If not, we continue this track with similar kinds of short educational streams. Okay, that's me signing off. Ciao.